quick video on solubility here. Okay, so you have copper sulfate, which is a water-soluble copper salt. When sodium hydroxide, a strong base, is added, the copper becomes its hydroxide form here, and the sodium sulfate is formed. Copper's in 2+ state here, the anionic sulfate is 2-, and copper's 2+ here, and the hydroxide is a -1, so there's 2 hydroxides to compensate, as shown above. So copper hydroxide is useful. It's used in the synthesis of aryl amines. So for example, here you've got a para-substituted benzene here, so this R could be any old nonsense, and this X usually a bromine or a chlorine, but could be iodine possibly. So you have secondary amine here, because obviously it's not fully substituted, you still have 1 hydrogen, and that's basically used for when the halogen leaves to form the BH or BRH or the CRH. So the copper hydroxide is used in tandem with THF and ethanol, the solvents, to form this. So as you can see, the H has been kicked off the amine, and the bromine or halogen, whatever it is, has taken that H, because obviously there'll be an intermediate structure of this, because the amine lone pair will attack this carbon, the benzene ring, because it's very delta negative, because it's got a halogen electronegatively pulling away electron density from it. You'll get a structure where it'll be SN2, because everything will happen in one go. The HN lone pair will attack, the halogen will be kicked off, float around as a minus, but it's quite happy. It's not perfectly happy, but it's quite capable of holding that negative charge. And then when this intermediate is formed, there will be a hydrogen attached here with a positive charge on the nitrogen. The halogens with its minus charge will come, attack like a base, steal the hydrogen, and because that hydrogen is so acidic, because it's attached to it's attached next to a positive charge, that the halogen will be able to very easily take that hydrogen and leave us HX. So that's what it's used for. Here, that's the copper sulfate solution. It's got a light blue tinge to it, nothing major. Here's the sodium hydroxide, so we add it in, see what happens. As you can see, there's a precipitate being formed, a very light blue precipitate. That is the copper hydroxide. So as you can see, it's gone from a very clear solution to having the suspended blue copper hydroxide solution. So just from changing the sulfate for hydroxides, changed the solubility of copper completely. So yeah, that's a quick video on solubility.